In a lot of headlines, fusion shows up as this magical, clean, limitless energy source that's going to solve everything. And yes, in the long run, fusion could completely change the way we power the world. But if you're trying to build a hydrogen project today, in the 2020s, fusion does nothing for your business model, your PPA, or your offtake agreement. What does matter today is something much more practical and much more bankable. Electrolyzers, cheap renewable power, smart integration, and realistic cost targets. Fusion is interesting, but electrolyzers are what you can actually design, finance, and build right now. In this video, we're going to get very practical. We'll look at what you can do today with electrolyzers, solar, wind, grid connections, batteries, and industrial heat, and how to set yourself up so that if fusion or other high-temperature sources become real later, they only make your existing assets better, not obsolete. If you're a developer, consultant, investor, or engineer, this one is for you. This is ReneEnergy.com, and we're here to talk about real projects, not science fiction. Let's start with where we actually are. Today, almost every serious green hydrogen project uses one of two main electrolyzer technologies, alkaline or PEM. High-temperature SOEC is promising, but it's still early in commercial deployment. Fusion is even earlier, so if you're planning a project now, your decision is not fusion versus hydrogen or fusion versus electrolyzers. It's much simpler and much more important. Which electrolyzer technology, where do you put it, how do you power it, and how do you make the economics work over 10 to 20 years? On the ground, what really matters first is your electricity. Electricity price and availability will make or break your project long before any big fusion breakthrough shows up. If you can secure low-cost power from solar, wind, hydro, or a favorable grid tariff, you can make an electrolyzer work. If your electricity is too expensive or too volatile, fusion can't save you because it's not here yet. That's why smart developers are obsessing over the basics, siting their projects near strong renewable resources, negotiating PPAs, using curtailed power, or tapping into off-peak grid tariffs to reduce average cost per megawatt hour. With that context, let's make this concrete. Imagine you're developing a 20 megawatts hydrogen plant today. Your realistic options are something like this: an alkaline electrolyzer with good capex and relatively simple operation, or a PEM electrolyzer that costs a bit more but handles fast-changing solar and wind better. Fusion is not in your decision tree. The real question is, how many hours per year can you run the plant, at what electricity price, and with what offtake? A 20 megawatts electrolyzer running at 4,000 hours a year looks very different from the same asset running at 7,000 hours a year. Your utilization, or capacity factor, is crucial. That's something you can manage today by combining renewables with grid power, maybe even adding a small battery to smooth short-term volatility. This is where things get much more practical than the fusion hype. Maybe you don't have fusion-grade heat, but you probably have access to industrial heat sources, waste heat from a power plant, a data center, or a manufacturing facility. You can't turn a PEM or alkaline electrolyzer into a SOEC overnight, but you can improve system efficiency with good thermal integration, better water treatment, and smart operating strategies. For example, using slightly elevated operating temperatures, optimizing stack current density, or recovering heat for district heating or process heat can all add incremental value now, even before high-temperature systems are mainstream. Another area where you can act today is technology selection and modularity. Fusion, if and when it arrives, will deliver high-grade heat and firm power. But your job right now is to choose electrolyzer systems that will still be useful in a fusion-augmented future. That means thinking about modularity, upgrade paths, and flexibility. If you select a system with rigid operating constraints and no ability to integrate with future heat sources, you might box yourself in. If you choose a flexible architecture, standardized skids, modular stacks, containerized balance of plant, you leave the door open for future hybridization, whether that's with advanced nuclear, industrial heat, or one-day fusion. Now, let's talk about AI and controls in a way that's useful today, not 20 years from now. You don't need a futuristic AI grid brain to improve electrolyzer efficiency. Even now, software platforms can optimize when your plant runs based on power prices, grid congestion, or renewable availability. Predictive maintenance can help you avoid unplanned downtime and extend stack life. Digital twins can simulate different operating strategies before you implement them. None of this requires fusion. These are tools you can deploy now to squeeze more value out of every megawatt hour and every kilogram of hydrogen produced. On the materials side, again, there is real progress already happening. You don't need to wait for some exotic fusion-compatible material to show up. You do need to pay attention to what your electrolyzer vendors are actually offering: stack lifetimes, warranties, degradation rates, and replacement costs. Don't just buy on CapEx and nameplate efficiency. Look at cost per kilogram over the lifetime of the plant. A cheaper stack with fast degradation might look good in year 1 and terrible by year 8. You can already benefit from improved catalysts, better membranes, and more robust designs. These are real, commercially relevant differences between suppliers, not future science projects. So where does fusion fit into this in a realistic way? At this stage, fusion is a potential future enabler, not the base of your business case. Think of it like this. If in 15 or 20 years fusion plants do come online and offer high-temperature heat and steady power, the big winners will be the developers who already have hydrogen infrastructure in place, electrolyzer parks, storage, pipelines, industrial off-takers, ready to use that heat and power. Fusion won't replace electrolyzers. It will try to plug into an existing, mature hydrogen ecosystem. The practical move today is to build that ecosystem, using renewables, grid power, and today's electrolyzers. That means focusing on things like off-take contracts, permitting, water sourcing, and infrastructure, which are popular to ignore in theoretical debates but absolutely decisive in real projects. You need to know who will buy your hydrogen and at what price. You need to understand local water constraints and whether desalination is required. You need to navigate permitting and safety rules for high-pressure hydrogen, compression, and storage. Fusion will not solve any of that for you. Those are boots-on-the-ground issues you must solve in project design. Let's say you are designing a project near a coastal industrial hub. You could combine offshore wind, some solar, a grid connection, and a 50 megawatts electrolyzer cluster. You might not achieve a perfect capacity factor, but with a smart mix of PPAs and grid contracts, you can reach a workable operating profile. You can start delivering hydrogen or ammonia to local industry, building relationships, long-term contracts, and trust. When, and only when, advanced heat sources like high-temperature reactors or fusion become available nearby, you can explore retrofits or hybridization. But your project will already be bankable and revenue-generating based purely on technologies that exist today. There's also a big financing reality check here. Lenders and equity investors in 2025 are not pricing in fusion. They're looking at proven technologies, stable cash flows, and clear offtake. If your project model relies on a speculative fusion input that doesn't exist yet, it won't get financed. If instead your model is based on solar, wind, grid power, and a solid electrolyzer with conservative performance assumptions, you have a chance. Fusion can be a future upside, not the foundation. That's a much more practical way to think about it. For developers, consultants, and investors, the key mindset shift is this: don't wait for fusion to design smart electrolyzer projects. Optimize what is under your control now: electricity sourcing, electrolyzer technology, plant layout, thermal integration, storage, and offtake. Use software and, where appropriate, AI to run your systems more intelligently. Stay aware of where fusion and high-temperature systems are heading, but don't build your current project around them. Build assets that are flexible enough to benefit from future upgrades, but not dependent on them. And that's exactly where H2Hub and ReneEnergy.com come in. Our focus is on the tools, templates, and frameworks you can use now to design real hydrogen and clean energy projects. From power-to-hydrogen sizing logic, to LCOH modeling, to risk registers, to offtake strategy, to how to think about integrating batteries and grid power with electrolyzers, we're focused on this decade's reality. while keeping an eye on the future. If you want to start or refine your own hydrogen project, or you're advising clients who are about to make big investment decisions, you don't need to wait for fusion. You need clarity, modeling, and practical structure. So here's the bottom line. Fusion might transform electrolyzer efficiency one day. It might give us cheaper heat, more stable baseload power, and incredible new ways of driving hydrogen production. But that's not your bottleneck today. Your bottlenecks are electricity price, capacity factor, capex, OPEX, water, permitting, offtake, and bankability. Electrolyzers are real, shippable, and installable now. Solar is real, wind is real, batteries are real, grid power is real. You can build a serious future-ready hydrogen project with those ingredients alone. If you want help doing that, if you want frameworks, templates, and guidance designed specifically for green hydrogen project development, go to h2hub.reneenergy.com. There you'll find resources built for developers, consultants, and investors who want to act this decade, not the next one. This is reneenergy.com. We keep an eye on the future, but we design for today. If that's the perspective you need, you're in the right place.